Good morning, everyone. I am Mr. Ish. Thank you for joining me. Let's look at a very interesting question here, an arithmetic progression question. You know, with an arithmetic series or an arithmetic progression, you have a formula such that your nth number is always your first number plus n minus 1 times d, where d represents a common difference. Each number from before or after is always separated by a common difference or a distance, and the nth number is always the one you're looking for. We have that formula. We also know that the sum of a certain number of numbers in that progression is always n divided by 2 times a1 plus an. We have that question here where the 20th number is 100 and the 40th number is 250. We have to find the first number and the sum of those 40 numbers. How do you go about doing that? You look at this formula over here and you put what you know. We know the 20th number is 100. So when you're looking here at the 20th item of the sequence, or the 20th number of the sequence, we know its value is 100, but we don't know the value of the first, but we know that it was the 20th number of that sequence, and we don't know the common difference. When we look at that 40th number of the sequence, we know in terms of its value it's 250, but again we don't know what the first value of this sequence is, but we do know that it's 40th number, and we don't know the common difference. But when you simplify all of this, look what happens. You have 100 is equal to a1 plus 19d, and then from here you have 250 is equal to a1 plus 39d. When you look at this right here, you know what you have over here. You have a system of linear equations. You can solve this out. Elimination. If you were to minus, you could easily cancel this out right here. You'd have minus 150 is equal to minus 20d. Here d would equal to 150 divided by 20. The negatives would cancel out. You'd have 7.5. So each number is 7.5 in distance from the one before or the one after. That's your common difference. You would take this value here, 7.5, and plug it into any of these. I'll plug it right over here. You'll have 100 is equal to a1 plus 19 times 7.5, and you'd calculate for a1 and you'd get a value, the first value of the series. You'd have 100 minus 19 times 7.5, you get minus 42.5. So you have a series over here which begins from minus 42.5, but then you add 7.5 each time, such that when you arrive at the 20th number, you're at 100. At the 40th number, you're at 250, and we can check it out. If you're starting from minus 42.5 and we're adding 7.5 each time, then the 20th number should be 100. But the difference between 1 and that 20 would be 19. So you could do 19 times 7.5 and you'd add that to 42.5, your very first number, and you'd get 100, which would be your 20th number. Don't do 20 times 7.5 because you're already starting here at 1. You only have 19 more numbers up to that a 20th number, so you have 19. So you do 19 times 7.5 plus this and you get that. Anyhow, let's find the sum of these 40 terms. We have to do that right here, and you know it's going to be n divided by 2, but n over here is your 40 divided by 2. Your first item here is going to be a1, which is minus 42.5. Your 40th item over here is exactly here, 250. Run it through the formula and you'll get the sum of those 40 numbers of that sequence. You do 42.5 minus plus 250. You can divide that by 2 and then multiply that by 40, and the sum of those 40 numbers is 4,150. So this represents here your sum of your 40 terms. We needed to know that, and we've done that, and it should be good, 4,150. The value of your very first question was this right here. The first term is minus 42.5, and that's done. So that's how you would do these type of questions, where you provided only part of the information. Then you have to convert everything into a system of linear equations, and you solve for one variable. Then with that you determine the other variable. The variables here were a1 and d. Once you have that, then you can easily answer the next question. And that's all I wanted to show you in this video. Thank you for joining me. Have a good day.